Hello everyone, welcome to the fourth lecture of the Gravitation chapter. My name is Abhimanyu Singh and I'm first year student at IIT. So in this lecture we will be firstly we will see few problems like around 10 problems based on the entire chapter. Then we will just recall entire concepts that we have studied in this chapter in just a simple manner. So let us begin. I have the first problem which says that three equal masses M are placed at three corners of an equilateral triangle of side A. Find the force exerted by the system on another particle of mass M placed at midpoint of side. So let us first draw this figure. What is the scene of the figure? It says that like M is there, M is there, M is there. And suppose it is placed at this side. Our another mass is placed at this side. So, uh, so suppose there will be a force of attraction like this, as it is a equilateral triangle. This will get cancelled because they are equal and opposite. As you can say, both the masses are same and it is the equilateral triangle. So the distance is also same. And we know that the force is nothing but gm square. There are same masses by x square, which is the distance between two masses. So we have only one force, which is in the upward direction, like this. So so we need to find this length, and that will our net force. So our net force will be like F is equal to, we have, mm, so this is A, and if we drop a perpendicular from it, and we know it is the equilateral triangle, so if we drop the perpendicular, it will bisect the side as well. So the denominator will be A by 2, and it will be a right angle triangle. So from Pythagoras theorem, we can write that. Suppose this is, let us say this side to be x. So x square plus a square by 4 is equal to a square. So what is the value of x square? X square is nothing but 3a square by 4. So we find the force. We have like 3a square and 4 will go in the denominator. So this is A. Now we have the B situation. I hope it look like equilateral triangle. So this is M, this is M, this is M, and the mass is placed at its centroid. So as we know that it is an equilateral triangle. So the distance of centroid from this, from this, from this is same. We know it. It is a common geometrical property for triangle, or you can prove it as well, because this is the triangle. This we have already known that it is like a root 3 by 4, and it bisects into 2:1 ratio, and in every case it will be like the same one. So we have this, but the force of attraction will be here. This will be F here. This will be F here. So let us see. There are three F, each at an angle of 120 degrees. So like we can do it one after one. For example, if we add, if we apply parallelogram law at these two vectors F and F, which are at angle 120 degrees. How it is 120 degrees? It will be 30 degrees as the angle is bisecting. It will be 30 degrees. It will be 120. So if we find that our new F prime comes out to be F square plus F square plus 2F square cos 120 degree. And what is the cos value of cos 120 degree? It is nothing but minus 1 by 2. So if we solve it, we just get a F, and we know that the resultant of two equal vectors bisect the angle between them. So it will be like this. But if it is a F, the above is also a F. So this F get cancelled. Hence, F net is 0. You can or you can make a general notation for any closed polygon. For any closed polygon of any size, the net field at its center is 0. Any regular polygon, the net field at its center, where it is a square, whether it is a hexagon or even pentagon, hexagon, heptagon, octagon, nonagon, whatever it is. For any regular polygon, the field at its center is 0. I'm not saying that they are rods. I'm saying like discrete masses placed in the form of a polygon. Hence, the field will be 0. Okay, you understood? Like we so forces are vector. We always need to remember that forces are vector. We can't like just like that add it like 1 kg potato plus 1 kg onion. They're different things. We can't add them like that. So now we have a second problem. We have a C 10 kg, 20 kg. So they have a separation of 1 meter, 1 meter initially. Then the separation reduced to 10, 20. Suppose its velocity is v1, we say it to be v2. Now we know that on the 10 plus 20 kg system, F external is equal to 0. Only force is the mutual gravitation force is 0. So what is conserved? If force is 0, then P is conserved. That is the momentum. So writing momentum conservation, we get V2, 10 V2 is equal to 20 V1. The initial momentum is 0 as everything was at rest. So when we like the final momentum, it is equal to 10 V2 minus 20 V1. Okay, as the direction are opposite. So it comes out to be V2 is equal to 2V1. As there is no friction and evolving forces are involved, no air resistance, no friction, we assume like that. So we can also apply energy conservation. On applying energy conservation. So firstly, initially what was it? Initially only was potential energy. So it will be like minus G 10 into 20 by 1. G m1 m2 by R. Kinetic energy was 0. Half 10 into V2 square. The kinetic energy of 10 kg mass plus half 20 into V1 square. And the potential energy term. G into 20 into 20, as it will be 1 by 2 and it come from denominator to denominator, and we will get like this. So if we'll do it, we get like 400 G, 200 G. So here we will get 200 G, and we change the variable. We change V2 is equal to 2V1. So it will be like 4V1 square. So it will be like 40 by 2, 20, 30 V1 square. Okay. And if we solve it, 0, 0 will get cancelled. V1 comes out to be root over 20G by 3. I'm not going to put the exact value. You can put it solve, but I don't think it is relevant. And V2 is like 80G by 3. In the terms, if we put the value of G, we get the exact velocity. Now let us move to the third question. What is third question? Semicircular wire has length L, mass M. A particle of mass M plays center of the circle. Find the gravitational force. Okay. There we have. It is a wire. The extra. I'm not focusing on the extra. This is for use. So it is like the axis. Let us say this is y-axis, and this is the x-axis. For the say of origins, and this is the origin. This is the center as well. Even though it not look like center, but it is the center. I'm assuming it to be the center. A particle of So this is the center. This is where mass m is placed. So like this is a continuous distribution, and when we have to find the field, we just uh, never use like the continuous setup. So firstly, at a theta angle from here, we cut an elemental segment. Okay, so here it will be like force will be like df due to this dm element. Let me change the color to write this dm element. It is of with d theta. Like we are drawing a triangle at theta, we are drawing something like d theta. And here it will be like force will be in this direction, df. You can see the direction of arrow, no? Yeah, it is clearly visible. And symmetrically, there will be another section at from this side. It will be also at an angle theta. From here, mass, we cut it like this. It will be also at theta. Okay. Now what we do is we shift the geometry of forces. If we see in x direction, like here it will be component will be df cos theta. Here also it is df, same as there. The value is same, but just the direction of forward. So df will get cancelled. So I will just have remaining a component in just the y direction. You can understand, no? I will be just having a component in the y direction, which is the df sin theta. So what will be the net force? Nothing, just the integration of df sin theta. Because the element of cos theta gets 0. Now we have to find what is the value of df. So df is g times dm by r square, which is a constant. Like the radius is the constant. So let us say the radius is like r. If the radius is given, then radius is constant. Okay, g dm by r square. It is, and now we have to find dm. So dm is nothing. Okay. See, we know that length of wire is equal to 2 pi r. Okay. So dl is equal to 2 pi r dr. 2 pi dr simply on differentiating both sides. So now dm is just total mass m divided by L into dl. Write it again, dl. So now we will change it to r because we need to find and like r terms. So m, what is L? It is 2 pi r into 2 pi dr. So we need to find it in terms of theta. Okay. M by pi, m by 2 pi, m by pi into d theta. It is just like this. M by pi into d theta. Because we need to find in terms of length. We need to find in terms of angle. So it will be like this, simple. M by pi into d theta. Let me put the value. G by r square. That is, r square is nothing but 4 pi square L square into n 4 pi square. It is the value of r square. And now dm. dm is nothing. Capital M by pi. Capital M by pi multiplied by d theta. M by pi multiplied by d theta. So into sin theta as well. I forgot the sin theta. So the integration will be like easy for you guys to do it. So at the angle lies between 0 to pi. And if we'll be integrated, we will get a 2. Sin theta will get to minus cos theta, and minus cos theta will give the answer. And minus cos theta will give a 2. It will be not 2 pi, it will be pi r because it is a semicircle. Sorry, it will be not be 4. So now pi will get cancelled. So it will be nothing, just 2 pi g capital M small m by L square. This will be the force. One of the major concept is like finding the symmetrical, finding two symmetrical points and then adding them vectorally. Not it will be just pi dr and writing it terms of that d theta with. Now we have another problem. It also involves a lengthy integration. Let us say so add theta element. We we cut an element of d theta. Here it is length dl. So there will be like one. It will be one direction. So say this is theta. Symmetrically, we cut another theta, and another strip. So here it will be 1D. Here it will be 1D. So the component of D sine theta get cancelled. As you can see here, it will be point like this. It will be pointing like this. So it get cancelled. So to find the net field, we we just need to for E to find. We just need to integrate the D cos theta. So it will be rotate from minus pi by 2 to plus pi by 2. Now, how to write the D? Let us say this distance to be Z and this distance to be X and this is D. So we write D as GM G DM by Z square, or you can say X square plus D square. And what will we write as DM? DM is nothing by M by L into dx. If we write DM is nothing but capital M by L into dx. So, and what is the value of cos theta? It is evident. It is just like adjacent side by, so it will be D upon or D upon Z. Let us say it to be Z. So now integrate it. Now let us write the value of integration. G M by L. Let us directly write M by L x square d square plus radius to the power 3 by 2 into dx, and the limit is minus L by 2 to plus L by 2. Okay, how the integration will be done? Integration will be done by putting x is equal to d tan theta. You put it and integrate it, you will get the answer, or you can Google it. The integration comes out to be, I don't remember the integration myself. So the answer is not like evident right now. It will, let me integrate it. Let me integrate it and I will write it here because it will be tough for me to integrate it on that. Let me integrate on the bit. It is nothing but L G. So like I will share it later. I will definitely. Let us move ahead. We'll do this. Now let us move to the next problem. What does it say? Find the force of particular place in tunnel at distance x from the center. So this is a tunnel and this is a long diameter. So find a particle of mass m placed in tunnel at a distance x. So so we know that the field inside a solid sphere is given by nothing capital M x by r square. So similarly here, force will be nothing. Force is the mass into the field. So it will be like G M small m, mass of earth it is actually, into x into r square. and it will be like towards the center of it. And it will be like a SHM. F is equal to KX. You can find the oscillation frequency like the. I don't think you have studied SHM, but when you study, you will know it, or you will do such problem, and you will find that like this is a SHM, and so this is like this. Now we will be like doing another problem. A tunnel is dug along a chord of earth at a perpendicular distance r by 2 from Earth's center. The wall of tunnel, assumed to be frictionless, find the force exerted by wall on particle of mass m when it has distance x from the center of tunnel. So this is one of the very important problem in gravitation for like competition point of view. It is very important. These type of problems are commonly asked, and many more adjustments can be done in this problem to ask new problems. For example, this problem mostly deals on the Newton laws, the forces, but we can also form a problem on this same concept using like the energy conservation, and very nice problems can be formed on this concept. So you need to understand this very carefully, how I am doing this. So this is the tunnel. So this is like a distance at r by 2. Okay. The object is at a distance x from the center. This is the center of tunnel, and let us assume it to be this side, and this is x. So the earth will be pulling it out with this force. This is angle theta. Let us say this is angle theta. We will break the force into two components, like the F sin theta is equal to the normal, is equal to the normal reaction, and F cos theta will be the one which will be given in the acceleration. This will be F sin theta. It will be balancing the normal force, and there will be F cos theta, which will be giving it the acceleration to move it along this line. So what is like the F sin theta? So when we write, it will be nothing. It will be G M, capital M. It will be like what is the distance? G M M. We know that it is X. So it will be like Z, R by 2X. Let us say this side to be Z. So it will be like Z divided by R square. And what will be the value of sin theta? Sin theta will be like, oh sorry, R cube. I'm sorry. It will be R cube. And what will be the value of sin theta? Sin theta is nothing, but it will be like mm, Z in the denominator. Oh, sorry. It will be that. Oh, sorry. I did a terrible mistake. This angle will be theta. We can also take this angle as theta, but when we take it, then the component will be f cos theta, not the f sin theta. So this has the angle as theta. So this is like then this is f sin theta. Sorry. Z, and in the numerator it is r by 2. So z gets cancelled. R gets r squared. So normal reaction is nothing independent of the position of mass in the tunnel. And what is the accelerating force? You can find the accelerating force. It will be nothing but the f cos theta. So it will be like doing a SHM. If you see, it is directly proportional to x. G N M Z R cube. Cos theta will be nothing. It will be using x by z. So z will get cancelled. It will be x, and it will be doing SHM, zigzag motion. Now we have a tough question. It is a very conceptual and fundamental question on the concept of fields. How do you visualize field? What is fields? So I think we should revise the content rather than moving to the next question. We have done sufficient questions. So let us do a bit of revision. So from where do we start the chapter? We started the chapter with Kepler law, which were based on data. We stated that the particle moves in electrical orbit, that the planet moves in electrical orbit, with sun as one of its foci, and the nearby position, and then we moved to the like law of area, which stated that equal. Okay, we have also one thing left from law of area. I remember I told you how like we get to the Kepler's second law mathematically using the Newton laws and the new data. How do we get to like the we have derived the t square proportion to a cube law. Now let us do that elliptical orbit law, like the law of area. How the that area is changed. Let us check. So suppose this is r vector. This is initial r vector. So vector. Now this is like this is final r final vector, like this is r prime after it rotates some angle theta, and this is like the ds vector, and the angle between r and ds is theta. Suppose we produce r here, we get theta. Now the area is given by of a triangle. It is like if two adjacent sides and the angle between them is given, we just do it like half r ds sine theta. Okay, it is the elemental area, so it will be like dA. It will be not dr. So, so dA will be half r. What is ds? ds is nothing, just v dt sine theta. And if we see what is r v sine theta, it is nothing, just r cross v. And if we multiply m, so we get m in the numerator and denominator. We get m r cross v by 2m. We are multiplying and dividing in denominator simultaneously, and we send the dt to towards there in the denominator. So we get dA by dt, which is also known as aerial velocity. dA by dt, m r cross v by 2m, where m r cross v is nothing, the angular momentum. What is it? It is nothing. Sorry, m r cross p, and mv is the momentum, and r is the position vector, and it is nothing, L by 2m. And what do we know about L in case of central forces? We know that L is conserved. Like L is constant throughout the motion. What will be the initial value of L? That will be the final value as well. So L will be conserved. So dA by dt is constant. That implies the rate of change of area is constant. And here in the if you see the geometry, here the geometry is like quite tough for you guys. And it will be also tough for me to draw like how we draw the perpendicular and find the area. You can just see that the area is like this. We get the area expression like this. Okay. So I think I have to cover one more point in this series. It was nothing. It was about black holes. So black hole is like we know that this is not revision actually, but we are just covering some lacked out points. Black holes. If escape velocity, that is VE, is greater than C, then it is a black hole because light cannot even escape from it. That's why every light stays there and it is black in color. So, and the radius is very small and mass. So we know that escape velocity is nothing proportional to mass and radius. It is under root relation, radius. So mass is very high. If you know about if we put a black hole matter on a spoon full of, it will be more heavier than Himalayas. It is just a fact. So the escape velocity is directly proportional to mass by radius. So mass is very, very high and radius is very, very small, which makes the escape velocity very high. Hence, even it, the light, sometimes the escape velocity becomes so much high that the that even light cannot escape from it. So this is like it. And now let us recall the points left. So firstly, we what we did was Kepler law. Kepler law was first was elliptical orbit. Second law stated that the equal area covered in equal interval of time. The third law stated that the time period is directly proportional to the square of time period is directly proportional to the cube of the semi-major axis. So these were the three Kepler law. Then we moved towards Newton's law of gravitation. We stated that force each and every particle in every mass in the universe attract each other by a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So the force between two point masses came out to be G m m m1 m2 by r square. Then we came to know about principle of superposition. So, for example, there is group of masses. The force due to them is same as the sum of the vector sum of the forces or vector sum of the forces between all two. Means like we just need to vector sum the every force and we get the net force. So this was principle of superposition, which is based for calculating the electric field and potential. And then we came to about how do we calculate. Like for discrete objects, for discrete masses, we do the summation, and for the continuous distribution, we do the integration. These were the 2 points, and then we see like what is field. Field is like instead of directly finding force, we first find field, and we just do F is equal to m. F is equal to m. Then we came to know about also the dimension of electric field, etc., etc. And then we also discussed about potential. Like what is potential energy of conservative force, and what is the relation between potential energy and work done. And then we also see the potential energy of a point between 2 point masses at distance at a separation r is nothing minus g m1 m2 by r. Then we see about what is potential. Potential is nothing but u by m. Then we see the most important result of this chapter, which I told you. It is dv minus e dot dl. E dot dl. Then we did two common type of problems, which were like how to find potential when field is given, how to find the field when potential is given. And we write dl as a 3D vector dx cap, dx I cap, dy j cap, dz k cap. And we just do the dot product to find this. And for finding electric field, we just do ex, partial derivative. If we want to find the x component of the electric field, we do minus del v by del x. That is differentiation of the potential function by keeping y and z constant and differentiating just with respect to the x. Then we move to the next point, which was the common field of the shape. Like we first did the ring, and the potential it was simple one, minus gm by z at an axial point, gm by z, where z is equal to x square and it will be r, and z will be like this. And when then we move towards the field. So field was nothing. Mm, Field was like, what was the field? Yeah, the field was like gmx by 2z cube. It was the field. Then we do about like hollow sphere. Hollow sphere, we came to know that the potential inside is constant, which is gm by r in a hollow spherical shell. Gm by r, where r is the radius of the sphere, and outside it varies like gm by r. It is just like a point mass placed at the center. For hollow sphere and solid sphere, for calculating field and potential, it is just like a point mass placed at center. And potential inside a solid field was like 0 inside, and outside it was gm by r square. Now for sphere, the potential inside was tough one minus gm by 2r cube 3r square minus r square. This is potential inside, and for outside it is just like a point mass space at center, which will be like gm by r, where r is distance from center. And then we move towards uh, for field inside, it is like, it is also important, gmr by r cube. Okay, and gm by r square, just like point mass placed. And then we move towards the variation in g. Suppose, like, if we move h above, we get g prime is equal to, it is approximation formula when h is small. And if we move h depth below in earth, we get g prime is equal to g into 1 minus h by r. These can easily be derived. You don't need to memorize it. You just we need to memorize one thing, like the value of g is directly that is equal to the value of electric field at that point, and you need to just remember the formula of electric the field of a solid state. So it will be like this, and due to rotation at an altitude of theta, the value of g prime is g minus, it is also very important, omega square r cos square theta. Remember this cos square theta, it is not cos theta, it is cos square theta, like this. And then we study about like the satellites. What is geostationary satellite? What is geosynchronous satellite? So geostationary satellite is that which all geostationary satellite that Earth, like the Earth seen and that it is at rest. So like the time period is same as Earth, and it lies in the equatorial plane of the Earth orbit. And then it just lies above 36,000 feet above the surface of Earth. And from center, it is like 42,000. You need to remember this data. The equatorial, the orbit is like 36,000 from the surface of Earth and 42,000 from the center of Earth. And now there is geosynchronous satellite, which not necessarily lie in equatorial plane, but it has time period equal to the Earth. So we came to a conclusion that every geostationary satellite is geosynchronous, but not all geosynchronous are geostationary. So then we came to know about escape velocity, which was nothing. VE is nothing, just 2 gm by a, which was like the velocity needed to send Earth outside its orbit. And we came to about the satellite velocity, which is required to move into a circular orbit of radius a, which came to be gm by a. And then we did the analysis at which velocity we will get what kind of orbit. If we give a velocity of equal to v naught, we will get a circular velocity. If we give a velocity like in the range of v naught and v, we get an elliptical orbit. If we give exactly is equal to escape velocity, then it will move towards infinity in a parabolic orbit, parabolic shape, not orbit, because it is not closed. And when we give it like escape velocity, more than escape velocity, it move in hyperbolic path. Okay. And how do we find the escape velocity? The basic fundamental is like the energy conservation. And then we move towards the elliptical orbit, in which we analyze that angular momentum is conserved. First point was L conserved. Second was E conserved. E conserved. These were the basics in this chapter. I don't. So now we are done. And then we like discussed about black hole, etc. We just did it recently. And escape velocity, we also did it. And let me, we also did like this. We also did electric. Okay. So we will have one more class in problem solving, one or two more class on problem solving. In the next class, we will be continuing few easy problems. And in the last class, we will do like some tough problems. Okay. So thank you very much. Best of luck.